Having said that, I've already said this once, but obviously it'll hit home every time I say it.
You can just simplify that one, right?
No, you already did. Straight away, you went back. Which makes it around all of a sudden not really big. Tyler, done? No.
I might be done.
You might be.
Maybe 38 or something. I might be done, I might be done.
Well, I mean, you could be both. That's always an option. That's looking plausible. Because I don't actually know what it is, I just know what I answer.
Oh, which hence why you got your answer.
What?
What did you get?
Go, alright.
Is that a question?
Alright.
What did you get, Zach?
I don't know.
I got walking over there.
Can I please borrow?
What do we have? 3 out of 5.
City racer, man, city racer.
Is it?
Five, 6,
Rubber man.
5.
Can I please borrow
Seven.
Gum?
Okay.
Oh, I'm glad.
Yep, let's go.
Yeah.
Call it Gum.
Didn't see that.
Well, Dean's out. Alright, so,
Kidnap, please.
first move, what do you want to do?
You want to
Remember
square
the
the root of 5?
We have to square this sucker, right?
So it's just 9/25.
45 minus from here.
You can just turn that one into 8/5.
Go, you're going to move that. This guy.
That one becomes 35/5.
Okay, right, so straight away, you've done a smart thing and switched over to 35 and 5. Why?
Because it's easier to take away from everything else if it's all the same.
Right, you want things to be the same because then you can operate with them in the very next line.
Wait, but how do I get
So you
it?
step forward and go on, hang on, I know what's going to come up. I'll make life easy for myself straight away. Smart, move.
And then
Cool, next thing.
5/1
Oh,
minus
so-
9/25.
Okay, so,
That didn't work for me.
okay, so if we go, how many people did that? For that bit? 1, 2, 3.
You can simplify it later.
Right, okay, so you've made the number bigger.
You can square it back into a 5.
Right, you could just instead go, oh, hang on, 5 times what, something on 25 is just
9/5.
on 25,
Oh my god.
which saves you dealing with bigger numbers. Yeah? Whenever you can, always try to find cheap, easy things to cancel. It saves you time and effort. Right.
5 times
Wait, what?
9.
No, 25.
No,
wait.
5,
Oh, geez.
5, my bad.
See, I was
Sorry,
right. I was like,
sorry.
doubt myself again.
Sorry. Yeah, sorry. So always try to cancel things wherever you get them for free. Right? You don't have to, but if this goes to 45 on 25 and then you decide, oh, you know what, I'll change all of these to 25s, that's going to suck because you're going to have to times this by 5, this by 5. Timesing by 5, not the worst, wouldn't be absolutely painful.
Not great.
But if these are 7s or something, and then you're going, oh, okay, I'm going to have a 7 squared here, so now I need to times these by 7. It's just the odds of you making an error start to go up really quickly. You want to irritatingly accept the fact that you are human and realise your limitations and go, how can I mitigate my own stupidity? Go. What do we get from here? So minus 9 is minus 45. Yep. Cool. All right. Got the value somewhere? Yep. Okay. Cool. All right. How do we know if that's a reasonable answer? Look at it. Yeah, go TJ.
Oh, yes.
Yep.
Because you know that the turning point is just
I forgot about the power.
lower than 7.
Lower than -7, right? So we know that it has to be at least as negative as -7. What's that?
That's like -8.
-8 and a bit, right? Almost -9. Yeah? So that is below this, seems reasonable.
Probably more.
It's not ridiculous. If this was negative 2084 over 5, would we be concerned?
Yeah?
Well,
Yeah, why?
Because it's a big number.
Because it's big enough, so but it's below this.
Not that much below.
Right, how do you know it's not that much below?
Looking at the graph, everything's like seems slightly to scale, so having a 2000 there would not make sense.
Right. Cool. This is, what did we say? This is roughly 2, this is roughly -1, this is roughly That's exactly -7.
That's not roughly.
There is no way this could be 2,000 and something, right? Or even if it can't even be 100, right? So we can rule out absurd values. Most of the time if you make an error, it will go to an absurd value. And you can very quickly go, nah, I'm human, that's annoying, go again. So we get negative
Nah.
24 on 5.
Isn't it with any equals 4 billion trillion would do one?
Cool, beautiful, happy. Alright. That's that. Okay. Was that a fair amount of work?
Yeah,
Yeah.
it's an easy
Okay.
shortcut.
I'm going to do the exact same thing again, in a
Why?
slightly different way.
It's gonna cheat.
Oh, easy way, let's go.
Okay, so now, will this always be easier? Not necessarily. So you have to, at some point you have to like judge, you know, which way I'm going to go with this, right? And that's totally up to you. It doesn't matter because in the end you should get to the same endpoint. The way that I would do this for this one, 50-50. Could go either way because 5 is not such a bad number.
We're doing 3H and 3
Go. 3, 5, particularly since this is an even number, that's really nice. Cool, so we get 9 on 25 plus k has to equal -7, which will change into -35 on 5.
Oh no.
Cool. Therefore, k equals -44 on 5. Did I do that right? Oh no, it was already 7 on 5. Whoops, that's a 7. Sorry. So this is now, what have we got? -18 on 5.
Okay.
Does that seem right? Oh no, this is on 5, that's on 25. Start again. So I've got 9 on 25 plus k equals on 5 -35 on 25. There we go. Oh, that's why I changed it for 25. K equals -44 on 25. So we get 5 bracket x minus 3 on 5 squared minus 44 on 25 equals 5x minus 3 on 5 squared minus 44 on 5. Okay. 1, 2, 3, 4, 5, 6, 7. Maximum 7 lines. 1, 2, 3, 4, 5, 6. About the same, particularly if you have to do a bit of certain work. About the same distance, right? From that, what can I know? Turning point for free. Right? 35, -44 on 5, which we already know is right because we did it before.
Yeah, we did.
Cool, alright. What could I also do? I could make this thing equal 0. Right? Get the x-intercepts straight away. Okay? So make this whole thing equal 0. We'll change colour to orange. Just pick a colour. Okay? So now I've got 44 on 5 equals 5. X minus 3 on 5 squared. Move this over, so I get 44 on 25. Take the square root. Add a 3 on 5. Equals x. Take the chair, because that's not too low for these. Cool. Okay. Root 44, so that's, oops. So that's 2 root 11 on 5 plus 3 on 5 equals x.
Oh no.
Look at that, that's the same as that.
Wow.
Whoa. Cool. So for less work, you get everything. Right.
This is upsetting.
Now, pros and cons, always. With different strategies, there'll always be different pros and cons. If these numbers were like, I don't know, 23, 7, and 17, right? Which way would you prefer to go? That one would be better. Right? Why?
Less room for error.
23, 7, 17. Do they have anything in common?
7. No.
They're all prime, right?
Tiny fractions.
Right, did I say 27?
23.
23, right. So 7, 17, and 23 is what I said, yeah? Yeah, all prime, right? That's going to suck when you're trying to do fractions because you're going to always have to multiply to the biggest one. right? Whereas with this, you're going to multiply them anyway, it doesn't really matter that much. There's only one multiply in there. The surd might be a bit ugly, but that's as good as they'll get. Go. Right. For things that are nice, 5, 6, 7, this one's probably slightly quicker. However, you open yourself up to potential problems if your fractions aren't up to scratch. Right, so there's risk and reward in both. So it just depends what you want to do. This one generally is more useful for other things that we'll do later as well, but this still works. Cool. The last thing is, okay, for the quadratic formula, way back here. For the quadratic formula, sometimes it gives us no solutions, sometimes it gives us 2 solutions. Can it give us 1 solution?
Yes.
Yes, okay. What determines how many solutions you're getting?
0 positive and negative.
0 positive or negative for what?
That's square root.
Right, this square root part. Cool. So I'll write with the square root originally. Ooh, that's terrible. Sorry. Squared minus 4ac. Okay. So if this inside bit is greater than 0, what happens?
It's 2 examples.
2 solutions, right? Why?
Because
Because you get this plus minus out front, yeah? Cool. If this thing is exactly equal to 0, what happens? You get 1 solution, right? Because plus and minus 0, you don't move. So you get 1 solution. Cool. If this thing is less than 0,
No solutions.
no solutions. Why?
Because you can't root a negative.
Right, we can't take the square root of a negative in methods. Cool.
Yep.
Brilliant. Okay. Well, it would be nice if this thing had a name so that we didn't have to write d squared minus 4ac. Right? So we're going to give this thing a name.
Ooh.
Right? Do anyone know what the cherry's going to be?
Peter.
Triangle.
Top.
Not quite, Peter.
Delta?
Okay, so the symbol is a triangle, which is a delta.
Oh, of course.
Right? So that's the symbol. Do we know the name?
trying to move.
The discriminant?
Discriminant. There it is. So delta equals this expression. The name for it is discriminant. Discriminant. What does that discriminant sound look like?
Discriminate.
To discriminate. When you're discriminating, what does that mean? Not necessarily racism, but it can be racism. Right, you're separating, right? You're classifying, you're separating things into classes. So this thing, the discriminant, discriminates between 2 solutions, 1 solution, no solutions. Cool? Now, this thing, most of the time, you won't use it, to be honest. Right? That's in 3i, 3h. So 3h is all the quadratic stuff. 3i is discriminant specific. However, there will turn up things in that 3i where you won't know what b, a, and c are. So it'll have m, n, it'll just have extra things floating around, and so you have to go through this and go, okay, if m squared is bigger than 4ac, whatever the numbers are, then I would have 2 solutions. But if it's this, then I'll only have 1. If it's this, then I'll have none. So it gets more general. Cool? I'll let you get into that as you go through it, because the first half of it is like just numbers, so it's boring. It's just like, it's this many solutions, great, boring. And then eventually it'll start throwing in more variables, and then it becomes, hang on, if this number is this big, then it'll be 2 solutions. If it's not that big, it'll be exactly 0, or if it's smaller than that, then it'll be 12. But that,
Is it like good to double check to make sure, like, so if you've got 2 solutions, it's good to check if you're supposed to have 2 solutions?
yes, however, how do you get those 2 solutions in the first place?
That's true.
Yeah, you use it in the first place. So it's like, it's a dependent check, not an independent check. So whatever you did once, unless you make the exact same error twice in a row, then you're gonna, like, it'll never, You get what I'm saying? I think that's everything I wanted to do. Yeah, so my drive home point is twofold. One, whenever you've got fractions, always try to cancel things to make life easier on yourself, small numbers easier to deal with. But more importantly, quadratic formula is a last resort, generally. Because all it does is give you solutions, and even if sometimes it will fail to do that. So you only use it when the numbers are so horrific that it'll take too long to do it any other way. Questions, queries? No, everyone's happy? Great. I think that's everything that I need you to be happy and good with by the time you come back after summer.
That's great.
Right? I'm going to add in one or two other things, but they are very much just a, what if we do this? Just a curiosity sort of thing. They're not hardened, they're not rock or essential, they're just like icing.
Are we doing chapter 4 next week?
We're doing chapter 4 next week. One day.
I have like 5 games left.
Yeah, I'm going to see you one day next week. Yeah,
I'm not
I'm giving you booklets next week, and I'll run through one out, but you don't have to really deal with that so much. It's 3G. 3G is the extra idea. I don't need, I should make this abundantly clear now, 3G you do not have to do. That's the thing that I'll do next class. It's like, if you're interested, do this dead last. Right? It's like, oh, okay, you know, it makes you think a bit, but that's it. Cool.
Ah, good on you.
Yeah, we come back to first bit.
Alright, 3H time. Time to work.
Yes, go nuts.
Oh, do you want to?
Whatever you're up to, this is 3H and 3I, if you're not up to date, you might need to go back, but, yeah. Yeah, it's too much for a moral code. Hit this one, that one's got one hand.
I'm deeply upset.
Hopefully you're still centered. Yes, cool. I think I can turn you off now. Bye-bye.